Configuring our enterprise network. And here I have a switch and 6 computers connected to it. I'm going to go to my switch, CLI, enable, configure terminal. First thing that I'm going to do is that I'm going to rename the switch using hostname SW1. You can see that the name on the CLI has changed, and I'm going to enable secret Cisco123 so that I can have an encrypted password to access my switch. What I have now is that all of my computers are on the same network, so I'm going to start configuring VLAN. So I'm just going to type VLAN 10, and I am configuring a VLAN. I'm going to name it IT, and that's it. Exit. Now I'm going to configure VLAN 20, and I'm going to name it sales. Exit. Now I'm going to assign a port. So those 2 computers, they're going to be in the engineering VLAN. They're connected to the switch on the fast access 1 and 2. Now I'm going to assign a port. So those 2 computers are connected to my switch on the ports fast access 1 and 2. So I'm going to type interface, range, fast access 0/12, switch port mode access, switch port access VLAN 10. Now those 2 computers are on VLAN 10. Now I'm going to exit and do the same for sales. So interface, range, fast access 0, 3 to 4, switch port mode access, and switch port access VLAN 20. Then I exit. Now I'm going to configure a single interface fast access 05 to be on VLAN 10. So interface FA05, switch port mode access, switch port access VLAN 10. Exit. Now I'm going to configure the VLAN interfaces. I'm going to start by interface VLAN 10, and I'm going to give it the IP addresses of 192.168.10.1 and a mask of 255.255.255.0, which is basically a /24. No shutdown. Exit, and I'm going to do the same for VLAN 20. So interface VLAN 20, IP address. This is of 192.168.20.1. No shutdown, and exit. I'm going to configure the switch to handle out IP addresses. It's basically going to be a DHCP. So first I'm going to exclude the address 192.168.10.1. That's going to be the default gateway for VLAN 10, and I'm going to do the same for 20.1. Now I'm going to create the DHCP pool for VLAN 10. So IP DHCP pool and VLAN 10. So the network is going to be 192.168.10.0, and the subnet mask is going to be 255.255.255.0. The default router is going to be 192.168.10.1. The DNS server is going to be 8.8.8.8, and exit. Now I'm going to do the same for VLAN 20. First, I'm going to create the DHCP pool, so IP DHCP pool and VLAN 20. Network is going to be 192.168.20.0, and the same subnet mask. Default router is going to be the .1. DNS server is going to be 8.8.8.8, and exit. The layer 3 switch is now acting as the DHCP server for both departments. Now, let me see if it worked. So first I'm going to go to my first PC on IP configuration, and on DHCP I see that I got an IP on the right range. And if everything worked, if I go to a computer on another VLAN, I should get an IP on that range. So if I switch to DHCP, requesting an IP address, and I get an IP on .20.2. I'm going to do the same on this computer. Desktop IP configuration, DHCP, requesting IP address, and I get an IP on .20.3. Those 2 computers are on VLAN 10, and those 2 computers are on VLAN 20. So if I try to ping from this computer to this computer, it's going to work. But if I try to ping from this computer to this computer on another VLAN, it fails. We haven't yet configured inter-VLAN communication, so for now, only computers on the same VLAN can communicate with each other. So right now, if I want to allow a computer on a VLAN to communicate with a computer on another VLAN, I gotta go to my switch, go to the CLI, and just type IP routing. After that, I can simply access the command prompt of this computer on VLAN 10, run ping 192.168.20.2, that's a computer on VLAN 20, and it works. 0% packet loss. So now, through the switch, I have enabled inter-VLAN communication by using the IP routing command. Add 2 more computers to my network. So I can connect them to this switch, but at some point I'm going to run out of available ports. So I'm going to add another switch, but I want this computer to be on VLAN 10 and this computer to be on VLAN 20. right now I have a problem. This cable connected to Fast Ethernet 01 on this switch carries traffic only for VLAN 10. Now I want to somehow connect those two switches using one cable that is going to carry traffic for VLAN 10 and VLAN 20, so that I can have this computer on VLAN 10 and this computer on VLAN 20. And I'm going to do that by using a trunk port. So I'm going to connect the two switches using a copper straight through on Fast Ethernet 07 on switch 1 to Fast Ethernet 01 on switch 2. And then I'm going to connect those two computers to this switch. I'm going to open switch 2 CLI, enable, configure terminal, host name is going to be switch 2, password, enable, secret, Cisco 123. To create the same VLANs that I already have. So VLAN 10, name IT, and VLAN 20, name sales. So now I'm going to configure the trunk. On switch 1 on the terminal, enable, configure terminal. On interface FA07, switch port mode trunk, and switch port trunk allowed VLAN 10 and 20. No shutdown, and exit. Now on switch 2, I'm going to do the same. So I'm going to run enable, configure terminal, interface FA01, switch port mode trunk, switch port trunk allowed VLAN 10 and 20, no shutdown, and exit. Now, if I run show interfaces mode trunk, I can see that FA01 is on 802.1q encapsulation is on, and the VLANs allowed are 10 and 20. And of course, the status is trunking. Now, after configuring the trunking, I'm going to configure the access ports for PC8 and PC7. So I ran enable, configure terminal, interface FA02, switch port mode access, switch port access VLAN 10, and exit. So I enter interface FA03 and switch port mode access, switch port access VLAN 20, exit. Now let's see if they can get IPs from this switch. So on this computer, I'm going to go to desktop, IP configuration, DHCP, requesting IP address, and it was successful. I'm going to do the same for the other PC. Desktop, IP configuration, DHCP, requesting IP address, and it's on VLAN 20. Let's see if a packet can pass through. Success. Awesome. So it works. Now, from this PC on VLAN 20, I'm going to try to ping this PC on VLAN 10. And it works, but I didn't enable IP routing on this switch. And I don't have to configure IP routing on this switch because the packet is going to go to switch 1 and it's going to go to switch 2 through the trunk, and then it's going to reach the destination. Our small network is working and computers on VLAN 10 can communicate with computers on VLAN 20. But imagine that you have a larger network with 10, 15, 20 VLANs, and the CISO comes up with a security requirement saying that VLAN 10 should not be able to communicate with VLAN 20, VLAN 30 can communicate with VLAN 40, but not with VLAN 50. How are we going to configure that? We're going to use ACLs. So I'm going to create an access control list. I'm going to go to my switch 1, enable, it's asking for my password, configure terminal. I'm going to run access list 101 deny IP 192.168.20.0, and that's important because you have to use the opposite of a subnet mask that you use. So if you have 255.255.255.0, in here is 0.0.0.255, and 192.168.10.0, and again 0.0.0.255, which is the opposite of 255.255.255.0. And what this simply means is that I'm denying communication from VLAN 20 to VLAN 10. That's it. And then I'm allowing everything else. Now I'm going to allow it to VLAN 20 with interface VLAN 20, IP access group 101 in, and 101 was in my access control list rule. If you remember from before, computers on VLAN 10 and computers on VLAN 20 could communicate freely, but now if I try to send a package from VLAN 10 to VLAN 20, it fails. So the access control list is working. Traffic coming from VLAN 20 and going to VLAN 10 is being dropped by the switch. And on switch 1, I can actually see the ACL in progress if I just type show access lists, and I can see my rules and how many packages are being dropped. All of my computers are getting their IP addresses through DHCP that was set up on switch 1. I can introduce a security challenge. Maybe an attacker, maybe an employer, maybe someone wants to set up a rogue DHCP server. This would be more realistic by using Kali Linux and connecting through Wi-Fi, but just for you to understand, an attacker could set up a server that is also going to distribute IP addresses to new computers joining my network. So for example, when a new legit computer joins the network and wants to connect to my switch or to my Wi-Fi and receive an IP address, something called the DORA process starts. DORA stands for Discover, Offer, Request, and Acknowledge. So first the computer only has a MAC address, and when it joins the network, the computer sends a DHCP Discover broadcast asking, hey, is there any DHCP server available on the network? And then our legit DHCP server responds with a DHCP offer, suggesting an IP address, a subnet mask, a gateway, and everything. So the computer is going to send back a DHCP request confirming that it wants to use it and use the offered address. And finally, the DHCP server is going to send a DHCP acknowledgement. Officially, it's going to assign to this new computer its IP, subnet mask, everything, and then it's going to be able to communicate with all the other computers on the network. But a race condition might happen. If there is a rogue DHCP on my network, then whenever this computer asks for an IP address and asks like, is there any DHCP server available, then this server might for any reason be able to answer faster than my switch, and then my PC11 would receive its IP address, subnet mask, and everything from the rogue DHCP server that is controlled by the attacker. And if it happens, the malicious actor that controls the rogue DHCP server can send me to different domains, he can block me internet access, he can do a bunch of stuff. So I'm going to protect my network against it by enabling DHCP snooping on switch 1. So I'm going to go to my console, enable, enter my password, configure terminal. And to protect my network, I only need to run IP DHCP snooping and IP DHCP snooping Vlan 1020. DHCP snooping turns my switch into a security filter. It decides which ports are allowed to send DHCP responses. So now on my switch 2, I got to configure it so DHCP offers coming from this cable, the trunk cable, are trusted. So I'm going to run enable, enter my password, configure terminal, and I'm going to select the interface where the trunk is connected to, and I'm going to run IP DHCP snooping trust, and then exit. And then to protect myself against the malicious actor trying to connect to switch 2 itself, then I'm going to run again IP DHCP snooping and IP DHCP snooping Vlan 1020. What have I done? This switch is only going to negotiate DORA through this port. So right now, if I exit everything and I run show IP DHCP snooping, you can see that the trusted port is Fast Ethernet 01, only this port. I can also see the switch DHCP snooping is enabled and it's configured for the following VLANs 10 and 20. Security engineers are doing a great job. All of my computers are updated and patched. It's going to be very hard for a malicious actor to get access over PC0. And if he does that, it's going to be very hard for him to pivot and reach to another device on my network. And then one of my wonderful employees thinks that it's a great idea to bring his laptop from home, and he says, okay, I just want to use some internet on my lunch break, and I'm just going to connect my laptop to the switch using this cable. What could go wrong? So many things could go wrong. And we're going to configure port security not to let this happen. Find out what's the MAC for PC0. So I'm going to go to its command prompt. I'm going to run ipconfig/all. And that's the physical address. That's the MAC for PC0. Now I'm going to go to my switch and I'm going to configure port security. So I'm going to go to CLI, configure terminal. So interface FA01, switch port, mode access, switch port, port security. Switch port security maximum 1. I'm specifying that I'm only going to allow one MAC address to connect to this port. And switch port security MAC address and the MAC address of PC0. Port security can learn MAC addresses automatically using sticky learning, or I can configure them manually. So sticky is easier to deploy because the switch learns the first connected device. while manual configuration gives me complete control over exactly which device is allowed. Then I'm going to specify what's going to happen when a violation occurs with switch port security violation restrict. So instead of restrict, I could use protect, which means that when a device that isn't allowed tries to connect, the switch silently drops its traffic. I'm using restrict, that also blocks traffic from unauthorized devices, but unlike protect, it logs the violation. I could also use shutdown, that immediately shuts down the port when a violation occurs. I'll leave it. I'm going to check my port security with show port security interface FA01, and it's enabled. The violation mode is restrict. I have the maximum of 1 MAC address, and I have 1 MAC address that was configured. Now, for example, from PC0, I can ping 192.168.10.3 and it works, 0% packet loss. Now, let's say that someone wants to get this cable and connect to this computer. I go to its command prompt, and I'm also going to ping 192.168.10.3, but it doesn't work. I'm getting a request timed out. And now if I take the cable and put it back to where it belongs, I open the terminal, ping works. So that's how you can use port security to only allow a certain MAC address to connect to a certain port on a switch, and unauthorized MAC addresses will not be allowed to use that port.